trig equations. Solve sine x equals minus 0.3 for 0 degrees less or equal to x less or equal to 720 degrees. What that meant is x can be equal to 0, or x can be equal to 720, or any value between 0 and 720. And we need to give the angle as in 3 significant figures. We're looking for x. So first thing I'll do is to say sine of x equals to minus 0.3. I need to divide both sides by sine because I'm looking for x. So x equals 1 over sine. If I'm dividing by sine, I'm also multiplying by 1 over sine, because if you're dividing by something, that means you're multiplying it by 1 over something. So I'm multiplying it by minus 1 over sine times minus 0.3. And in indices, we know what that is in indices. 1 over sine is sine to power minus 1. 1 over something is something to power minus 1 in indices. So that's just a reminder of the indices that we need to understand. So now this is what we want. If we get the calculator now, so I press shift sine to get my inverse sine and put minus 0.3 there, close bracket, and the answer is minus 17.457. So I'm going to choose minus 17. So x equals minus 17 degrees. Right, x equals minus 17 degrees is what we're going to use to find the answers to this problem. Okay, now I've drawn myself a unit circle. What that meant is that the radius of the circle is 1. So that's the radius here, it's 1. That radius is 1, 1, 1. So in this case, this is actually 0, and that is 1. That is x equals to 1, that's y equals to 1, that's x equals to minus 1, and that's y equals to minus 1. So what I need to do now is remember that what we're looking for is, if I draw minus 17 degrees, just to a rough rough guess of minus 17 degrees. So here's minus 17 degrees. And actually, let me extend it to that point. And I also want to draw plus 17 degrees. So again, that's a rough guess of what it is. I'm not making it perfect. Okay, so we've done. Here is minus 17 degrees, and that is plus 17 degrees. But what happened is we don't count our angles in, so that would be 17 degrees here. And well, here will be 17 minus 180, because that's 180 degrees. If you take a 180 from 17, I think you'll be getting something like 163. So that'll be 163 degrees. If you add 180 here, and here will be 17 degrees as well. So add 17 to 180, you'll be getting 197 degrees. And here will be 360, take away 17 degrees. So I'm expecting 343 degrees, right? Okay, so that's actually what's happening is we have to go 0 to 17 degrees here. That's how, and then from there we go all the way to 163 degrees, 197 degrees, and then back to 343 degrees. Now, let's now answer this question. We want sine of an angle that gives us minus 0.3. Well, if I extend my line there, I get my y value. This is a unit circle, so that means r equals 1. But my sine is always equal to, sine of 17 degrees is always equal to sine, the y value is always equal to sine x. But sine x, what they gave us is actually, so in this case, that will be 0.3 because that angle represents the angle of 17 degrees. But here, because this is positive y, this is positive y from 0 to there, 0 to there, that's y, that's 0.3. If you go along that way as well, if you extend that down, because that line is corresponded to that line, so that will be y is also equal to sine of x, and that is also 0.3. If you then extend that line to there, now this is y again, is also equal to sine of x, but that equals to minus 0.3 because it's negative value of y. In a unit circle, your y value is your sine and your x value is your cosine if you're using unit circle. So right here I'm using unit circle. And so this is your negative value, and here too, look, because it's coming down here. So your y is your sine of x equals to minus 0.3. So what are we looking for? Are we looking for plus or minus? We want minus 0.3. So we are looking for these angles here. So the angles we're looking for is this one here. So the x value will be equal to 197 degrees, and that one here, because that's negative y as well, which is sine, because sine is opposite over hypotenuse. So y over 1, which means sine of x will become y, because it's y over 1. So that's why we're saying that your y value is your sine. And the second value will be 343 degrees. Now, but the question is, we've done from 0 degrees now, less than equal to x, less or equal to 360 degrees. But we need to go to 270. So we need to go twice. Right. Going twice is very important. So you have to pay attention to this. So now you start from here now, right? So you're starting from there, which means you're adding 17 to that. So you go to there is 17. 17 plus another 17 plus 180. You see? Because you go from there back to there, that's 17. And then you add 180 to that, because it's in a straight line. And then you add another 17 to get to your next point here. Because what we need is this, so we just go twice. So go from there to there twice. So that would be, get my calculator up and go, so put that in there. So we got 343 plus 17 to get to 0 degrees, and then add 180 plus 180 degrees, and then add another 17 to get to 197 again, plus 17. Okay, so that gives 557 degrees. So that's where we're going, because we're going twice now. And then we need to get back to the here again, because we need to go twice to 720, because 360 times 2 is 720. So if we times that by 2 is 720. So we need to get back to here again. So to get back to here from 575 degrees, so you need to add, or you could do this, 720 take away 17. 720 take away 17. So get your calculator in there nicely, right? And you go 720, that's 360 times 2, take away 17, and you get 703. So the final angle we need is 703 degrees. So that covers that domain, between 0 degrees and 720 degrees. These are the angles that will give the value of sine x equals minus 0.3. So why don't we check it and plug these values in and see if it satisfies the values we've got. So all we need to do now is go right. Sine 197, close bracket, we get minus 0.29, so that's 0.3, minus 0.3. Okay, that's good. What about sine? Just put sine 343, close bracket. Again, you get minus 0.29, so that's 0.3. What about sine 557, close bracket. Again, minus 0.29, so that's good. What about sine 703 degrees, close bracket? Again, minus 0.29. So that's awesome. So those are the 4 values we need. So really what has happened here is that all of them, all the 3 Triggs ratio problems, which is the sine, cos and tan, all of them are positive here in the first quadrant. So in the first quadrant here, see if I get my pencil, in the first quadrant, right, that's the first quadrant, all of them are positive. So what do you mean all of them are positive? Well, what I meant is that sine is positive, cos is positive, and tan is positive. In the second quadrant, so second quadrant is this bit here and that bit. In the second quadrant, so sine is positive, excuse me, cos is negative, and tan is negative. And in the third quadrant here, so that's the third quadrant, so sine will be negative, and tan, because that's opposite, that's negative over negative, so tan will be positive, and cos will be, because that's it will be negative here, because that's cos here, so it's cos is the x value, so that's negative. Tan is opposite over adjacent, so tan is sine over cos. Here you can see sine is positive here, so that's positive because sine, y value is sine, and y value is sine. Cos is positive here, so tan, well, y sine over cos is tan. Okay. Likewise, here x value is negative, so that's your cos, so cos is negative. Y is negative, so sine is negative. Tan is negative over negative is positive. On the fourth quadrant, what's going on there on the fourth quadrant? Yeah, on the fourth quadrant, you're going to get sine, because if you look at it, sine is positive, that's your cos, and your sine is negative, so sine is negative because it's negative here, and cos is, well, positive because your x is positive, and your tan is negative over positive, so tan will be negative. Negative over positive is negative. So that's what's happening in the unit circle. And the answer we're looking for is this answer here.